Welcome everyone to this week's latest in Bitcoin tech session. Today we'll look at another quantum proposal. It's titled Quantum Aware HD Wallets. So these proposals are all addressed towards handling the post quantum reality. So many s- may, because the protocol is very complex and has a lot of moving parts. There are multiple proposals that are being put up in order to address specific areas of the areas of the protocol. There can be one single proposal that does everything. It has to be piecemeal. That's how the network is. That's how the protocol is. That's how development is. So, given that context, today we'll see something about a proposal. This proposal is all about imagining or trying to draw a rough sketch of how your wallet structure could be in a post quantum world. Because in a post quantum world, as the signature signing algorithm changes, you get to lose a lot of features that elliptic curves have given us. Elliptic curves have really been an awesome algorithm, signing signature algorithm, and they have a lot of benefits. And we have like constructed a lot of schemes and conveniences and derived a lot of features out of these properties of elliptic curves. But in a post quantum world, it is going to change. And how are we going to accommodate or try to retain or modify some of the features that we currently use with respect to wallets? So that's what this proposal is all about. So we'll go through the problem statement, then we'll get to discuss about what are all the existing workarounds that exist with respect to the problem statement. Um, then we'll briefly see why you have to understand this and why do you have to care about this, and then what are all the what is the proposed solution that particular proposal brings to the table. Then we'll also look at the challenges involved in implementing this proposal, and also there are a lot of arguments in favor and a lot of arguments against this proposal. So we'll have a look at these things so that we can have um, a good balanced view of this particular proposal. And if time permits, we'll also look at a very basic or very top level inaccurate understanding of the Sphinx algorithm. However, it will not be very technically detailed or technically correct, because that is a session in itself. The point of introducing Sphinx here is to help us understand how Sphinx is complex when compared to elliptic curve, and why is it difficult with with respect to when viewed in the perspective of elliptic curves. So in order to understand that, we'll basically go through the rough idea of Sphinx, what Sphinx is. So that's a brief outline of today's session. So with respect to the problem statement, so as I said, we have Bitcoin since its inception has been using the SEP 256K1 elliptic curve. Um, this curve is currently being challenged with the advent of quantum computers, and people constantly working on Shor's algorithm, which is an algorithm that uh, when used on a quantum computer can help you break the discrete log problem. The discrete log problem underpins the security feature of SEP256K1, SEP256K1 curve, which is nothing but you can derive a public key from a private key, but you can't. You can derive a public key from a private key, but you can't go the opposite direction. Given a public key, you can. It is mathematically infeasible for you to derive the private key. So this is what SEP256 K1 curve gives us, and this is what is being currently under threat with the rise of quantum computers. So now the question is, how do we prepare our wallet structure that we are currently using for a world where the quantum threat is real, or even though um, the uh, the the time line of the quantum threat is up for debates, but we have to get ourselves ready for any kind of eventuality. So that is the whole point of making these proposals and discussing as a community around these proposals and finally settling down on something. So in this case, how do we preserve our familiar wallet structure that we currently use, which is seed phrase, HT wallets, and then you derive various addresses from these HT wallets. So how do you preserve this workflow? Because people are even this workflow is difficult for people, and if we have to like move to a completely uh, new workflow which is alien to this whatever we have been using so far, that would be very difficult for adoption. There will be a setback uh, to the adoption, and also even technical Bitcoin users will find it difficult to migrate. So the essence is we must try to maintain the same workflow, wallet workflows, while also adding quantum resistance nature to it. So that's the problems. That's what the problem statement is all about. Um, so um, how do we preserve the existing wallet structure in a quantum safe world? So this is the problem statement. So any questions or points of discussion around this? Okay, great. So the existing workarounds, so let's say we don't have, um, we don't we don't arrive at a solution for this problem. For example, we don't arrive at a solution for how the wallet structure will be after the when we start using post quantum signature schemes. If we don't have a solution, what do we do? We'll have to like stick to some very rudimentary poor UX solutions, such as do not reuse addresses. So uh, if you don't want to like if we don't have a good solution for the quantum threat in terms of signatures or in terms of wallet structures, then we'll have to resort to being very very careful with with our addresses. We can never reveal, we can never reuse the address, and also when spending from an address, we will have to like spend the entire address out, including the change into something new, into a new address whose public key has never been revealed before. So we'll have to do all these kinds of jumping over the hoops in order to be careful about with respect to the quantum threat. um, and that is one existing workaround. The other existing workaround is if we don't have this kind of a if we don't have some provision in our existing HT wallet structure with respect to a clean quantum migration path, then the other alternative or workaround is like wait for some emergency to hit us, and then force migrate or scramble people into something into something very alien and new. So that is the other uh, workaround that currently exists. So these are all not ideal. So we must start looking into better, well structured solutions rather than just waiting around and doing some stopgap arrangements. So uh, as a average Bitcoin user, why should you care about these kinds of discussions? Is because uh, these discussions are not just cryptographic technicalities that are being debated, but it has implications on long term self custody. For example, you are of the type of uh, buy it and then forget it type, then you should be very careful. You should have some awareness about these proposals that are being discussed and what is being adopted, because you will have to do some form of migration eventually. It may be in 5 years, it may be in 10 years. That is up for debate, but you must be ready for migration. And if you have been aware, or if you have been following these debates, you will be in a position to make educated guesses. If not, you will be forced by whatever influence that is being forced on you. So and also having awareness about these discussions will help you be calm and not panic and mess things up when a quantum threat eventually surfaces. So that's why you should be cognizant about what are all being discussed and what are all the solutions that are up for grabs for you, and make some educated decisions around the options available to you. So, so, that sort of sets up the context for the quantum aware HT wallet problem that we are trying to provide a solution or find a solution to. So now let's get into the proposed solution itself. So the proposed solution is around creating a quantum aware HT wallet. So if you can see the currently you have a seed phrase, and you go about uh, deriving HT wallets using BIP32. So you get a series of address, you have child, you have parent, and a bunch of stuffs that are derived from just your seed. The new idea or the quantum aware HT wallet is that you have a seed phrase. However, you just don't derive uh, uh, SEP 256K1 based addresses, but you also derive something called as a quantum aware HT wallet, which means there will be two components inside each address. One will be your normal pending path, or Schnorr signature based pending path, which you can use without experiencing any change in the user flow. But coupled with each and every address, there will also be a provision which this proposal assumes to be will likely be Sphinx, but that might not be the case. But anyway, this proposal doesn't have any hard coded features built in for only for Sphinx, but not for other quantum safe algorithms. So you'll have a normal spending path or normal key, so that you can keep spending as you do today. However, there will also be uh, an emergency provision, such as say Sphinx plus key embedded along with it. And once there is the when the threat materializes, you can switch to using Sphinx. So that is the overall idea or sketch of the proposed solution. We'll go a little bit more into the details. So So the normal path is designed to be used every day, and you will hardly notice any changes with respect to your normal spending. But when the threat materializes, when the post quantum when there is a need for a post quantum usage, you can easily switch or easily activate the Sphinx spending path. So that becomes active. Um, the idea is that you don't have to abandon your seed phrase completely and then swipe everything into a new seed phrase, which will also come with its own security risks, and the chance of messing it up will be higher, and it becomes a costly process. If in terms of single sig, it might not look like a costly process, but if it's a multi sig and which also involves a lot of complex setups, then you are looking at a very costly and a risky migration path. So in order to avoid that, in the proposed solution, the post quantum spending paths and security features will always be rolled into every single address that you derive, and the moment when the moment arrives, you can start using those keys that are anyway embedded with your existing seed phrase. So in order to do that, um, it will obviously use it will obviously use a tree-like structure where there are two leaves or two spending paths. So it will typically consist of uh, it'll consist of a new type of extended key. For example, right now we have xpriv, which adheres to BIP32 and BIP44 standards. By adhering to that, from your seed phrase, you will typically derive an xpriv, which is the extended private key. Similarly, in this new post quantum HT wallet scheme, you will derive an extended key, which consists of uh, a quantum extended secret key and also a quantum extended public key. And this quantum extended secret key in turn will contain uh, chain code and also the sub 256 secret key itself, which is your normal xpriv, and also inside it will also be packaged the something called as a Sphinx's secret material, which is used in the Sphinx signing algorithm. So this is what will be rolled into a quantum extended secret key, and similarly, in a quantum extended public key, uh, will have chain code. It will have SEP 256K1 public key and the Sphinx public key. So all these things will be rolled into the quantum extended public key. So this is the new structure that is being proposed, and from this, you will you can one can start using uh, the the regular spending path, which involves SEP 256K1. Um, and whenever there is a threat, or whenever the user feels the need to use the Sphinx spending path, he can directly he can start using it. So the advantages of this proposal is that it will help us preserve the seed phrase. It will preserve our seed phrase. It will help us generate receive addresses. It will also help us generate change address. We can create watch only wallets, and also preserve our hardware workflows. So uh, the whole idea of this design is to help us preserve the existing HT wallet workflows rather than forcefully migrating to something new and alien. So there this two types of extended keys is just a surface level definition. If we go into the details of this, it is a little bit involved. For that, we need a good understanding of what how Sphinx itself works. So, before we go further, we'll just have a brief look at how Sphinx itself works. Not a very detailed description or a very accurate description. It's more of a rough sketch that will help us have uh, a broken understanding of Sphinx. But that I think is good enough. We can build on Sphinx technical understanding of Sphinx in later sessions. So we'll look at the signing and verification workflows. So it starts with the message that you want to sign. Then you hash the message, and then you it does something called as few time signatures or force signatures. So the digest the uh, the digest is arranged into a Merkle tree, and then you choose a path, and you reveal uh, the the path and the uh, final root final leaf that you are going to use. So this is the for signature scheme. Once you get the for signature, then you do something called as Winternet's one-time signature, and then there is again Merkle authentication path involved, and then this whole process is repeated across multiple layers. That is the process from 3 to 5, and finally you get the Sphinx signature, which is a combination of a bunch of stuffs, which is the randomness for signatures and the internet signatures plus the Merkle authentication path. So this whole package is called as is the Sphinx signature, and mm, and then to spend and then to verify it. Once the verifier receives the message and the signature, he goes through a similar process in reverse in order to verify the public key. I just glossed over the entire process because I'm also not very conversant or aware of the entire process in detail. But the whole idea is that you can see the computational complexity involved, and also the size of the signature itself. Uh, how 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 heavy the signature itself is, and also the verification is not trivial. It is also computationally intensive. So this is a brief overview of Sphinx for you. Uh, so this is the solution. Essentially the solution is to package two spending paths in the same address type, and whenever there is the threat, we can start using the quantum resistant spending path. I'll pause for a few seconds if you have any questions. Okay, cool. So as you might have seen, the proposal is not very uh, well thought out or well written. That's because it's in the very early stages, and it's an attempt to package our post quantum or fit the post quantum world into the existing existing wallet uh, types that we are used to. Obviously, it comes with a lot of challenges. The first biggest challenge is this proposal assumes that you will have a consensus change, that is a hard fork which will involve the activation of some opcode for a post quantum signing algorithm. So this proposal assumes that you will have op SX check sig, an opcode that can perform uh, verification for things, but that's just an assumption. It can be anything else, any other signature scheme that the community the converges onto. So that's the first problem. Second problem is Sphinx itself. Even though Sphinx is considered as one of the lightest among the post quantum signature schemes available, as we have seen when compared to SEP 256K1 or the elliptic curve, it itself is orders of magnitude heavy in terms of memory. So that's another problem. And also the the power of SEP 256K1 lies in its algebraic nature. Because of this nature, we are able to derive child public keys from parent public keys, and this power, uh, we will stand to lose this ability when we shift when we shift to Sphinx, because in Sphinx, because Sphinx is not algorithmic, sorry, algebraic, you won't be able to derive child keys from parent public keys. So this will force us to reuse public keys in Sphinx. Although that's not a problem in terms of quantum threat, it will be a problem in terms of privacy. So, so that is another problem. And of course, Sphinx computation is resource intensive. So that puts a big task or big problem with respect to hardware wallets and what we have optimized hardware wallets for right now. So that's a big problem ahead. And also, even though we might preserve the HD wallet nature, uh, different wallets have like different modes of operation. There are wallets that save the seed phrases in the device itself. Some wallets don't save the seed phrase, rather they just save the expriv. Depending upon the structure or stage of wallet usage, the migration will be patchy, and this proposal currently does not address all those issues. um, so these are some of the challenges involved. However, there are a lot of arguments in favor of this proposal. The first and foremost thing is that it it tries to preserve the HD wallet nature or structure. Mm, and also, everyday normal transaction will remain unnoticeable or normal until there is a actual verifiable quantum threat, so that people don't get forced into heavy post quantum signatures right now, uh, just because they are afraid of a Q day. So this one helps us mitigate that problem. Then also it takes into consideration the long term holders nature. So there are a lot of Bitcoiners who sort of withdraw it to their address and then sort of forget about it. So if if you do it on some other structure and you forget about it, and some day in the future you might get back to your address, and the protocol might not even recognize or validate, or might have forked past these old addresses. Then you will stand to lose. But this proposal, if it becomes mature enough and if it gets adopted, that problem is that problem is solved. So that's the argument. And also, it sort of helps avoid the emergency migration bottlenecks. So there won't be a sudden push for people to migrate, and and people can do it in their own timeline, and you can gradually build awareness and help people move their funds. So this is a step in that direction. So these are the arguments in favor, and arguments against it. Uh, it The classic argument of did the egg come first or the chicken come first? So are we adding? So it's a question for us: are we adding complexity before the threat is there? So that's one argument against it. Then the other argument is it's completely dependent upon or assumed it is assumed that there will be future consensus forks consensus fork that maybe via a hard fork or a soft fork, nobody knows. There will be opcodes that will help verify post quantum signature schemes. So that's another assumption. And of course, the problem associated with Sphinx itself that we have discussed so far, and the privacy problem as we did. So that's an argument against this proposal. Even with Sphinx, you might end up losing quite a bit of privacy because public key reuse will become prevalent, and uh, yeah, and it's not very foolproof. The UX is not great. UX is not as smooth as what we have now, and also it's not very foolproof because you must be careful about uh, the Schnorr public key itself, because you also have Schnorr public key, and also you also have Sphinx best public keys. But while using Schnorr public keys, you must be careful and use all precautions that apply to a standalone Schnorr public key itself. So these problems are all there. So yeah, it's not a very complete proposal or idea, but it's a step in the right direction. So yeah, any questions? So that was about the whole hierarchy quantum aware HD wallet idea.